Hi, in the screencast today, we will learn how to perform a chi-square test in R, as well as how to perform some other useful commands. In Microsoft Excel, chi-square test can be computed with the command chi-test, so C-H-I-T-S-T, T-E-S-T, but it requires you to calculate the table of expected frequencies yourself. Hence, today we will work with R only. You may remember that the chi-square test enables us to test whether there is a significant statistical relationship between two categorical variables. We will stick to the simplest case of two binary variables. So we have one independent variable that takes on two values, 0 and 1, and one dependent variable, also of binary nature. We will perform an analysis of the relationship between the developing status of a country and the share of women in its parliament. Please load the dataset with international organizations' staff numbers. Note that, again, we are using a decimal comma as a separator, not a dot. And you should get used to automatically checking these technical things before any data import. So opening the dataset in a notepad will simply show you that commas and not dots are used as decimal separators throughout the text or throughout the data. So in the dataset, we have a continuous variable called female parliament, which takes on values between 0 and 100. This captures the percentage share of women in the parliament. Let us recode this variable now into a binary one, which will divide all countries according to whether they have at least 25% of women in their parliaments or less. Hence, we will want to create a new variable called female parliament 22, for example, in our dataset staff_data. So let us create this new variable and let us assign to all the lines, all the countries, the value of 0. It should be here. In the next step, we will assign this variable value 1 for all those lines where the share of women is larger than 25%. The way how to select these lines is by specifying in square brackets the condition. In our case, the condition is that variable staff_data $female parliament, the original one, is larger than 25. Using this condition in square brackets, we assign value 1 to our new variable female parliament 25 to all those lines of data in which variable female parliament has value 25 or more. We can check in the dataset that some of the lines have changed, and we can check that, for instance, this line 1, 2, 3, 4, number 4 is Australia with 26.7% of women in the parliament. Once we have it, in order to perform a chi-square test, we will first need to create a table with the numbers of observations of countries that fall into all the combinations of the two variables values. If we have two binary values, we have 4 different cells. The command to create a table in R is surprise, surprise, table. And in our case, it will be table as here, and then in brackets, first the dependent variable, so female parliament 25, and then after comma, the independent variable developing, both with their dataset assigned and using the $sign. I will call this new variable, sorry, this new table, my table for chi2, for chi-square. So it has been created here. It says that the new table is here. We can check what it looks like. And here it is. Now we perform the chi-square test using the command chi-sq.test, so chi-square.test, with the name of the table we have just created in brackets. This command will calculate the chi-square statistic. Here it is around 13.8. The calculation has 1 degree of freedom, as you will not surprised to learn having followed our discussion in the class. And the analysis shows that the probability of no statistical relationship between the two variables is extremely low. It's 0.00019. That means basically that the chance of the null hypothesis being correct is only around 0.2%. So there is a 99.8 probability that indeed the relationship between the two variables exists, the statistical relationship. So developing countries are more likely to have 25% of women in the parliament or less than developed countries. Note that this does not tell us how strong the relationship between the two variables is, just that the relationship is statistically significantly different from 0. However, we can use the gamma coefficient to find the strength of the relationship. To use the command, we will need to install the package called VCD Extra with capital E. I have already installed it, so I will just load it with the command library. We already have our table called my table for chi2, for chi-square. And to get the gamma coefficient, we will simply use the command gk gamma, gk in capitals, and then the name of our table in brackets, so my table for chi2 in brackets. We find the gamma coefficient of minus 0.71, so a very strong negative relationship. Developing countries with independent variable equal to 1 can be expected to score on the dependent variable 0, so to have less than 25% of women in parliament. So this is basically it for the chi-square test and the gamma coefficient calculation. Before we finish, I would like to show you a couple of useful commands in R. First, let us have a look at how we can rename variables. In order to rename a variable in R, we can use the following command, where we insert the name of the dataset of the old variable, so of the dataset of the old variable, and of the new variable, the new name we want to assign to an existing variable. So for example, we can rename our variable country into country X, for instance, in our dataset staff data. And we can check that the variable has changed its name. Well, an easier alternative would be not to rename the variable using this longer command, but simply to create a new one by assigning or creating a new variable which will be given exactly the same values as the old one. So for instance, we can now recreate our original variable called country using this simple command which is known to you. And we should find a new variable country at the very end of our data set, indeed. But note that this time we haven't deleted the variable country X. We haven't replaced the variable, we have created a new one. On the next lines, we see how to drop some variables if we want to tidy the dataset up a bit. We can insert the names of the variables we want to drop in brackets here, and then insert the names of the original larger dataset and of the new smaller data set with the variables dropped. So perhaps we want to get rid of the variables GNI and population in our data set for whatever reason. So we have our data set staff data, GNI population, and again here staff data, and we will call the new smaller data set staff data 2. And indeed, running the code creates a new data set with these two variables less. So they are not here, they should be here in this section. Sometimes we want to order the data set according to the values of some variable. This will obviously not change anything in the data, it will change only their appearance. And this code tells us how to do it. We just need to insert the name of the old dataset, of the unsorted older dataset, the name of the new sorted dataset, and the name of the sorting variable. So let us order our dataset by the values of the variable internet, or share of people in population with internet connection. So the name of our older dataset, and here the ordering variable internet, again our old dataset, and our new sorted dataset, and let's call it staff data internet sorted. So let's run the code, and indeed a new dataset has been created, and we can check that the dataset is ordered by the share of population with internet connection from Sierra Leone, here at the top, with 0.2% to Iceland with more than 90% of people connected to internet. But note that these data are not completely up to date. In fact, I guess they cover the period around year 2007. Finally, here is a way how to merge two data sets. This may be useful sometimes when we get our data in two separate data sets with a common variable. We can then merge them on the basis of this common variable. In order to do it, we simply need to insert the names of the two data sets we have prepared, so dataset 1 and dataset 2 for instance, and of the identification variable that is common to both the data sets. For example, this could be country, or whatever variable uniquely defines your unit of analysis. And this way we would create a new dataset called merged dataset. So this is it for today, and next time it will get more exciting with the regression analysis.